Hello and welcome to the channel. This video is about American Mathematics Competition, AMC for short, organized for high school students by the organization named American Mathematics Competition related to Mathematical Association of America. 2021 ACM 12B, I assume for 12-year students, took place on the 10th of February 2021, and it looks a bit harder than Competition 12A happened earlier this year. The problems and solutions are available from the site Art of Problem Solving AOPS. The link to it will be placed under the video. The site also has the answer key, convenient for someone who, like me, prefers to try solving independently. All the solutions presented here are checked with the answer key. Solutions from the site were also helpful sometimes. Here are the first 5 problems from the competition. As usual, I advise you to pause the video and try solving. Problem 1. How many integer values of x satisfy in equation absolute value of x is less than 3 pi? The objective is to reduce this interval to integer boundaries. To do that, we write that pi is more than 3.1 and less than 3.2. A rather rough estimation, but it is sufficient this time. Multiplying by 3 gives 3 pi is more than 9.3 and less than 9.6. This shows that the integral part of 3 pi is 9, while the integral part in this case is strictly less than 3 pi itself. Therefore, for the integral values of x, the inequation absolute value of x is less than 3 pi is equivalent to the inequation absolute value of x is less or equal to 9. The last inequation holds if and only if x belongs to the interval from -9 to 9, including the ends. And since both ends are included, the number of integer values containing in this interval is upper end minus lower end plus 1, which is 19. Choice D. Vamos adelante al problema 2. At a math contest, 57 students are wearing blue shirts and another 75 students are wearing yellow shirts. The 132 students are assigned into 66 pairs. In exactly 23 of these pairs, both students are wearing blue shirts. In how many pairs are both students wearing yellow shirts? Let's don't get confused with that. There are blue shirted pairs, where both students are wearing blue shirts, of course. And mixed pairs, with one blue and one yellow shirt. And of course yellow shirted pairs with both yellow shirts. We need to find the number of yellow shirted pairs. 23 blue shirted pairs involve 46 students wearing blue shirts, while the total number of students wearing blue shirts is 57. This suggests that the remaining 11 students are in mixed pairs, so there are 11 mixed pairs. Now look at that from another point of view. There are 11 students in mixed pairs wearing yellow shirts. The total number of students wearing yellow shirts is 75. Subtracting 11 from 75, we get 64 students in yellow shirted pairs, which corresponds to 32 yellow shirted pairs. This is choice B. Allons-y. À la question troisième. It has a long continuous fraction that I am scared to read even. See if we can automate the process of finding x. Consider equation a plus b over y equals c, and solve it for y. We get y equals b over c minus a. We can apply this to the given equation, assuming y to be the whole denominator. Here we have a equals 2, b equals 1, c equals 144 over 53. And we get the value of denominator. Here we can multiply both numerator and denominator by 53, so 53 goes to the top, And we finally get 53 over 38. And we get a new equation which also has a big denominator, and we already know how to treat it. This time a equals 1, b equals 1, c equals 53 over 38. And we get the value of the new denominator, which can be simplified to 38 over 15. And for the last time, we do the familiar trick and get the value of 3 plus x, which is 30 over 8, from where we can find the value of x without any hassle. It is 3/4. Choice A. Avanti! Al compito numero 4. Miss Blackwell, here I expect a disclaimer. Names are fictitious, any resemblance to actual person, living or dead, is entirely coincidental. Why it is missing is a real mystery to me. So, the above-named person gives an exam in 2 classes. The mean of the scores of the students in the morning class is 84, and the afternoon class's mean score is 70. The ratio of the number of students in the morning class to the number of students in the afternoon class is 3/4. What is the mean of the scores of all the students? So it is given that the number of morning students is 3/4 of the number of afternoon students. To avoid dealing with fractions, let for x be the number of afternoon students. Then 3x is the number of morning students. We need to find the overall mean score, which is the overall total score divided by total number of students. But overall total score is morning total score plus afternoon total score, while total number of students is the number of morning students plus the number of afternoon students. Then we find morning total score as the morning mean score, which is 84, times the number of morning students, which is 3x. This evaluates to 252x. In the similar way, we find the afternoon total score. It is 70 times 4x, which is 280x. Adding up the scores gives overall total score, which is 532x. We also need to add up the numbers of students to get the total number of students, which is 7x. Now we are ready to find the overall mean score, which is 76. Choice C. Третьим la problema următoare. Numero 5. The point P with coordinates A and B in the xy plane is first rotated counterclockwise by 90 degrees around the point with coordinates 1 and 5, and then reflected above the line y equals minus x. The image of P after these two transformations is at minus 6, 3. What is B minus A? So let's draw the coordinate axis and plot point P double prime at location minus 6, 3. This point is the result of two transformations, and we need to find the location of the original point P. For that, we need to revert the transformations and do that in reverse order, of course. At start, we find point P prime, which is an image of point P after the first transformation. Then we can get to the original point P. Point P double prime is obtained from point P prime by reflection above the line y equals minus x. We know that line y equals minus x is the bisector of second and fourth quadrants. The reverse operation to a reflection is the same reflection. So we just need to reflect point P double prime above the line y equals minus x. To make it clear, let's project point P double prime to the coordinate axis. This gives points x double prime at location minus x 0 and y double prime at location 0, 3. Reflection about a bisector of coordinate axis transfers x-axis into y-axis and y-axis into x-axis. In our case, point x double prime is transferred to point y prime at 0, 6, which is the projection of point P prime to y-axis. Point y double prime is transferred to point x prime at minus 3, 0, as this is the projection of P prime to x-axis. Now we know the location of point P prime, which is minus 3, 6. But we still need to reverse the first transformation, rotation counterclockwise around point with coordinates 1 and 5. So let's plot point T with coordinates 1 and 5. The reverse of counterclockwise rotation is clockwise rotation. Therefore, in order to get the location of point P, we need to rotate point P prime 90 degrees clockwise around point T. To do that, let's draw a right-angled triangle P prime S prime T with the sides parallel to the coordinate axis. Let's find the coordinates of the right angle vertex, point S prime. S prime T is a vertical segment. Therefore, x-coordinate of S prime is the same as x-coordinate of T, which is 1. S prime P prime is a horizontal segment. Therefore, y-coordinate of S prime equals to y-coordinate of P prime, which is 6. So we know that the coordinates of S prime are 1 and 6. Now we can find the sides of the triangle. The length of side TS prime is the difference between y-coordinates of S prime and T. It is equal to 1. The length of side P prime S prime is the difference between x-coordinates of S prime and P prime. It is equal to 4. And the triangle P prime S prime T is rotated 90 degrees clockwise around point T, becoming triangle PST. Point S prime is transferred to point S, and the segment TS prime to segment TS. Rotation doesn't change the lengths, therefore the length of segment TS equals the length of segment TS prime, which is 1. This allows to find the coordinates of point S. Y-coordinate of S equals y-coordinate of T equals 5. X-coordinate of S equals x-coordinate of T plus the length of segment TS. And we get 2 for the x-coordinate of S. So we found that point S has coordinates 2 and 5. Now it's time to get the coordinates of point P, which is the image of point P prime. Therefore, segment P prime S prime is transferred to segment PS. The length of segment didn't change, therefore the length of PS equals to the length of P prime S prime, which is 4. Segment PS is vertical, therefore x-coordinate of P equals x-coordinate of S, which is 2. Y-coordinate of P is equal to y-coordinate of S plus the length of segment PS. So we add 5 to 4 and get 9. Now we know that point P has coordinates 2 and 9. This means that A equals 2 b equals 9. Therefore, b minus a is 7. Choice D. This completes the first block of problems. Problems 6 to 10 are not yet as strong as one would expect from a national level math competition. So, be positive and enjoy solving them before going on with the video. Also beginnen wir den nächsten Satz mit dem Problem 6. An inverted cone with base radius 12 cm, metric system in US, the sister price, and height 18 cm is full of water. The water is poured into a tall cylinder whose horizontal base has a radius of 24 cm. What is the height in centimeters of the water in the cylinder? Working with letters here seems more convenient than working with numbers. So let r small, standing for 12 centimeters, be the radius of the cone. H, which is 18 centimeters, is the height of the cone. Since the cone is full of water, this is also the height of water in the cone. Capital R, or 24 centimeters, is the radius of the cylinder. Finally, x centimeters is the height of water in the cylinder. The height of the cylinder doesn't matter as long as the cylinder is tall enough to hold the water, which is assumed. Of course, we all remember the formula for the volumes of a cone and a cylinder, so we conclude that the volume of water in the cone is the same as the volume of the cone, which is 1/3 times pi times r small squared times h. And the volume of the water in the cylinder is pi times r capital squared times x. If the water didn't spill while pouring, which hopefully is also assumed, the volume shouldn't change, so we can equate the volumes and get an equation for x, from which we find that x is 1/3 the ratio of r small to r capital squared times h. Substituting the numeric values, we get x equals 1.5, and since the value of h is given in centimeters, the result will be also in centimeters, which is what we need. 1.5 centimeters looks ridiculously small as compared to the original height of 18 centimeters. But this is choice A, and it agrees with the answer key. Doesn't it look to you pretty straightforward for such level of competition? Well, it could probably fit for number 1, at most number 2, but number 6 seems too much honor for this problem. Так вперед, гораздо более интересная задача номер 7. Let n be 34 times 34 times 63 times 270. What is the ratio of the sum of the odd divisors of n to the sum of the even divisors of n? Why am I getting so passionate solving problems involving even and odd numbers? Is that about evenness or, on the contrary, about oddity? Most probably it is related to the exclusiveness of number 2, the only even prime number, the smallest number into which you can divide but not always can do it entirely, and the only quantity giving equal chance of success and failure. Will this problem be enjoyable? It looks like someone started factorizing number n but was distracted and didn't complete it. So let's complete the factorization. We have 34 is 2 times 17, and this number repeats. 63 is 9 times 7, or 3 squared times 7. Finally, 270 is 27 times 10, which can be written as 2 times 3 cubed times 5. So, the factorization of n is complete. We see that any divisor of n can be represented as 2 to the power of p times 3 to the power of q times 5 to the power of r times 7 to the power of s times 17 to the power of t, where p is an integer between 0, corresponding to the absence of factor 2, and 3, when the factor 2 appears in its full power. This gives 4 possible choices for the value of p. In the similar way, there are 6 choices for q, 2 choices for r or s, and 3 choices for t. Using the multiplication rule, we can find the total number of divisors for n. A divisor is odd if and only if the value of p is 0. This leaves only one choice for p, so the factor 4 has to be replaced by 1 or simply dropped. On the contrary, a divisor is even if and only if p is positive, that is 1, 2, or 3. Therefore, in order to get the number of even divisors, we replace 4 by 3. Now we can find the ratio of the number of odd divisors to the number of even divisors, where after huge cancellations we end up with just 1 to 3. And this is choice E. But hold on. The question is not about the ratio of quantities. It is about the ratio of sums. This suggests that we have to add up all odd divisors, then add up all even divisors, and divide the first sum by the second sum. Can we do that? Probably yes. Will it be enjoyable? Certainly not. Fortunately, that false start wasn't a complete waste of time, because we learned something out of it. It can be observed that there was no need to completely factorize n. The only thing we really used is the power of factor 2. In general, any even number n can be represented as 2 to the power of k times an odd number, where k is a positive integer. In this case, the ratio of the number of odd divisors to the number of even divisors is always 1 to k, while the odd prime factors don't make any difference. So let's wipe out all unnecessary lines and explore the real question. Consider an arbitrary even divisor of n, number f. We know that the power of 2, number p, must be a positive integer between 1 and 3. Let g be the product of all odd factors. The product of odd numbers is always an odd number, so g must be an odd number. You may argue that the odd factors may not exist. In other words, q, r, s, and t could be all zeros. In this case, g is 1, which is also an odd number. Quite obviously, g is also a divisor of n, so we can write that g is an odd divisor of n. This means that any even divisor of n corresponds to a certain odd divisor of n. At the same time, any odd divisor of n, number g, can be associated with the set T of g, containing even divisors of n, which are multiples of g. We see that any such set consists of exactly 3 members, and the sum of the members, S of g, is 14g. It is important to note that any even divisor of n corresponds to one and only one odd divisor of n, therefore belongs to one and only one set T. The rest is pretty straightforward. We just write out all odd divisors of n, then for each odd divisor we find the sum of corresponding even divisors. By adding up all the sums, we get the sum of all even divisors. Common factor 14 can be placed outside the brackets, while the expression in the brackets is precisely the sum of all odd divisors. And we find that the ratio of the sum of odd divisors to the sum of even divisors is 1 to 14. Choice C. The result can be extended to any even number represented as 2 to the power of k times an odd number. In this case, all the even factors corresponding to a particular odd factor g form a geometric progression. And the sum can be calculated using well-known formula for the sum of the members of a geometric progression. So we get S of g equals 2 times 2 to the power of n minus 1 times g. Therefore, the ratio of sums is 1 to 2 times 2 to the power of n minus 1. The problem was enjoyable after all. Teraz przechodzimy do problemu 8. Three equally spaced parallel lines intersect a circle, creating three chords of lengths 38, 38, and 34. What is the distance between two adjacent parallel lines? So let's draw the circle and its center, point O. We see that two chords have the same length of 38, and this gives a clue to the correct drawing. Indeed, we know that the shorter is the chord, the farther it is from the center of the circle. Therefore, chords having same length must be equidistant from the center. Moreover, since the chords are parallel to each other, they must be located on the opposite sides of the center, while the center is just in the middle between the chords. So let's draw the two chords of size 38 and name them AB and CD, where points A, B, C, and D all lie on the circumference. So we can write that the length of AB is equal to the length of CD and equals 38. Next, we draw through point O the perpendicular to line AB. Since line CD is parallel to AB, this will be also perpendicular to line CD. Let K and L be the points where the perpendicular meets lines AB and CD respectively. So we can write that OK is perpendicular to AB and OL is perpendicular to AC. As it was mentioned, lines AB and CD are equidistant from the center O. Therefore, the length of segment OK equals the length of segment OL. Let x be the value of this length. Then KL equals 2x, and this is the distance between two adjacent parallel lines we need to find. Now it's time to draw the third chord. Chord EF. This chord is parallel to AB and CD, but it is shorter, so it is located further from the center. Without loss of generality, we can assume that EF and CD are located at the same side from point O. So let's write that the length of EF equals 34. Now let M be the point where the perpendicular KL meets EF. KL must be also perpendicular to EF. So we write that OM is perpendicular to EF. Another observation. Since lines AB, CD, and EF are equally spaced, the length of segment LM equals the length of segment KL and equals 2x. Now it's time to recall a useful theorem. A diameter perpendicular to a chord, which is exactly what we have now, bisects the chord. It follows that K, L, and M are the midpoints of corresponding chords. Therefore, CL is half the length of CD, which is 19, and EM is half the length of EF, which is 17. Now let's draw the radii segments OC and OE. We can write that both segments have the same length, which is r small, the radius of the circle. From the right-angled triangle OCL, we find the length of the hypotenuse using Pythagoras theorem. After substituting the values, we get an expression for r squared. Similarly, from another right-angled triangle OAM, we get another expression for r squared. Then we of course equate the expressions and find that x squared is 9 and x is 3. So the distance between adjacent parallel lines to x equals 6. Choice B. И противоположная эротическое автото диамеризма проблема энея. What is the value of logarithm base 2 of 80 divided by logarithm base 40 of 2 minus logarithm base 2 of 160 divided by logarithm base 20 of 2? So let L be that weird expression we are going to evaluate. The expression can be significantly simplified by using the following well-known identity. Logarithm base b of a equals 1 divided by logarithm base a of b. Here it appears more convenient to read it from right to left. So we get 1 divided by base 40 logarithm of 2 equals base 2 logarithm of 40. And 1 divided by base 20 logarithm of 2 equals base 2 logarithm of 20. After substitution into the expression for L, we get rid of all the fractions, and what is even more important, all the logarithms now have base 2. And we can also see that all the values under the logarithm are multiples of 20. So let a be base 2 logarithm of 20, and we are going to express all the logarithms in the right hand side for L in terms of a. So we have base 2 logarithm of 40 equals base 2 logarithm of 20 times 2, which can be written as the sum of two logarithms. The first term is just a, the second term is base 2 logarithm of 2, which is obviously 1. So we get a plus 1 for the logarithm base 2 of 40, and proceed to logarithm base 2 of 80. Again represented as the sum of two logarithms. The first term is base 2 logarithm of 40, and we already know that it is a plus 1. The second term is again 1, so we get a plus 2 for base 2 logarithm of 80. In the similar way, we find that base 2 logarithm of 160 is a plus 3. Substitute the values into the expression for L, and it works like a magic charm. All the terms containing a are nicely cancelled out, and we get just 2. Choice D. I wish all my life to be as simple as that. ועכשיו מתקדמים לתרגיל האחרון בחלק הזה. השאלה מספר 10. Two distinct numbers are selected from the set from 1 to 37, so that the sum of remaining 35 numbers is the product of these two numbers. What is the difference of these two numbers? The sum of all elements in the set is the sum of starting 37 natural numbers. And we know very well how to compute the sum. The sum S is 37 times 19, and we don't rush to multiply in case it might be unnecessary after all. A and B are the selected distinct numbers listed in increasing order. A is less than B. To get the sum of remaining numbers, we subtract A plus B from the total sum S. And the remaining sum is equal to the product AB. So we get an equation that has to be solved for a natural A and B not exceeding 37. To do that, we collect all the terms containing A and B in the right hand side, where we want to factorize somehow. There is no common factor for all three terms, but we can factorize AB with another term, for example A. This leaves alone term B, and in order to get it also involved, we add and subtract 1. Now b plus 1 is the common factor and we can complete the factorization. However, minus 1 looks odd here in both meanings. So we move it away and get a plus 1 times b plus 1 equals s plus 1. This looks really cute. However, it means that we actually do need to multiply 37 by 19. So 37 times 20 is 740, minus 37 is 703, and we need to add 1 to the result, which gives 704. Believe me or not, that was the toughest part of the task. Remember that a and b are no more than 37. So we write that 1 is no more than a, which is less than b, which is no more than 37. Adding 1 to all parts of the inequality, we find that a plus 1 and b plus 1 are between 2 and 38. The next step is of course representing 704 as a product of two distinct numbers between 2 and 38 each. Since 7 plus 4 is 11, number 704 is a multiple of 11. More precisely, 704 is 11 times 64 or 11 times 2 to the power of 6. This suggests that either a plus 1 or b plus 1 must be a multiple of 11. So let's write all the multiples of 11 which are no more than 38. 33 is dropped straight away since it is divisible by 3, while 3 is not a factor of 704. Number 11 doesn't fit either because in this case another factor would be 64, which is more than 38. So only number 22 is left, which gives 704 equals 22 times 32. And since a is less than b, we know that a plus 1 is 22 and b plus 1 is 32. The difference b minus a is the same as b plus 1 minus a plus 1, and it is 10. Choice E. The solution is complete, but for mere curiosity, let's check that it really works. We have a equals 21, b equals 31. The product AB is 651, and the remaining sum s minus a plus b is also 651. This is perfect as this completes part 1. We say goodbye to the video, but not goodbye to the assignment. Just click the link on the next slide for moving on to part 2.